Today I'll be showing you how I map the biotin synthesis pathway. I first started off on NCBI, specifically PubMed, to find a paper that could give me the biosynthesis pathway so I would know exactly what genes I'm looking for. I typed in biotin biosynthesis and Escherichia coli. The first paper I clicked on, I scrolled through it and then I clicked on the full text link, and then I scrolled through again after it's finished loading. Yes, and then I scrolled through the entire paper again to see if I found a pathway. I didn't really find what I wanted from this paper, so after a lot of scrolling to see if I missed anything, I got out of it. Then I looked for another paper that specifically talked about biotin synthesis and nothing about precursors or anything else, just specifically biotin synthesis. And I clicked on this second paper. And then I opened the full text link. And then I scrolled through until I found a pathway or a specific map of all of the genes. And thankfully, my second paper did happen to have a map, and it gave all of the genes you needed. And we only needed to begin with the pyomylyl ACP, so I just wrote down the genes that started in the middle, starting with BioH and then ending with BioB. I now know all of the genes I have to look up in order to make this biotin pathway. So then I went back to NCBI and I specifically went to the protein database, and the first one I searched was BioH, and I wrote and Escherichia coli K12 MG1655. It came up with quite a few results, so then I added the filter that we were taught earlier in the module, so I would get rid of redundancy. And this took me directly to a protein for BioH, which was labeled as protein methyl ester esterase. Then I scrolled to the bottom where it provides protein information, and there's usually an EC number there as well. In this instance, there were two EC numbers, so I clicked on both to see which one was the one that I needed. The first one was a carboxyl esterase, which is not the enzyme that we are looking at. So then I clicked on the second, and it was a methyl ester esterase, which is what we were looking for. So I recorded this EC number into my document. Then I went up to the FASTA area and copied the FASTA file, which had both the enzyme name and the protein amino acid sequence that we needed for this assignment. And then I essentially repeated this process another 4 times for all of the other genes that we needed to find, or specifically the proteins of the genes. So again, I wrote BioF and Escherichia coli K12 MG1655, and I searched, and again there was many results, so I added that filter to see if it would remove the redundancy and take me directly to what I needed, which it thankfully did. And then I scrolled down to find an EC number, which there was only one of, so I copied that down into my document. Then I went up again and copied the FASTA file containing the protein sequence and the enzyme name that we need. And then I repeated this again for the next gene or protein. It was BioA and Escherichia coli K12 MG1655. And I directly added the filter this time. And it took me directly to a protein again. I scrolled down. And there was a single accession or EC number that I copied down. And I copied the FASTA again. And of course, I did it again for the next protein that I was looking for. This process took me a while, probably roughly 10 minutes or so, to find all of the genes because I did every single one separately and manually. And here I had 2 results, so I read through each of the titles to see which one I would need, and then I just clicked on the first one to see if it would apply. I read through the different fields and entries and information here to see if it was indeed the protein I was looking for, and it seemed to match. So then I went down to the protein area to look at the EC number and as well as the other synonyms, and there was only the synonym BioD, so I decided that this applied and I wrote down the EC number. I then copied the FASTA, which contained the enzyme name and the protein sequence, which I needed for the assignment. And then I did the final one, BioB, the exact same way I did the other ones. I put in the filter so it would take me directly to the protein that I wanted. I saw here again that there were 2 results, so I decided to do what I did last time, to click on both, or one of them if it happened to fit what I needed. So I clicked on the first to see if it happened to apply. I read through, the information seemed to look good, but then in the bottom in the synonyms area, it had more than just BioB, so I decided to go look at the other entry. I looked through again, it looked good, went to the bottom to the EC number, and the synonym only had BioB, so it looked like it applied for what I needed, so I copied down the EC number. And as always, I copied down the FASTA file that contained the enzyme name and the protein sequence. I then did this Biotin pathway search a second way by starting on UniProt. Here I typed in Biotin Biosynthesis Escherichia coli. And I specified K12 MG1655, and then the first one seemed to work. As we know, BioH is one of the genes, and I went ahead and looked at it, saw if it applied. which we know it did, but I did it just to make sure, and it said that it was involved in biotin synthesis. Then I went to the external links and I clicked on Brenda because we learned that's involved in showing us the biochemical intricacies of different enzymes and such. And I didn't click on I didn't use the first one because it was for a different enzyme than we needed. The second one was for methyl ester esterases, which is what BioH is. Then I specified for what specific E. coli strain we have. And when I scrolled to the bottom, next to KEGG, I saw a Biotin Biosynthesis link here. And it provided me a map, as well as EC numbers, which I thought was very helpful. So I started with palmitoyl ACP, and then I followed the arrows down to where we needed to end at biotin. I wrote down the gene names and the EC numbers. For Bio A, there happened to be 2 EC numbers, but I decided to get there when I get there. I just copied down both. If I did everything correctly, the gene names and the EC numbers should be the same as what I did for the NCBI search. This method of working on UniProt was much faster than on NCBI, where on NCBI it took me roughly 10 minutes. On UniProt it took me around 5 minutes or so. So then, using the names that I found, the gene names, I looked them up. Oh, well, before that, I copied down the FASTA file from the sequence because we need to have both the enzyme name and the protein sequence, which I copied and pasted into my document. And then I searched the gene names along with Escherichia coli K12MG1655. I could have specifically put the EC number now that I'm looking back and I am doing this voiceover, but this is practice. I'm seeing how it works. And then once I clicked on the only result, I looked to see if the EC numbers matched, and they did. So then I went directly to the sequence and I copied the FASTA file again. For Bio A, on my document, I have 2 EC numbers, so I just wrote down the query, and it took me directly to one protein, and it had a single EC number. So I looked to see if that matched any of the ones that I had, and it matched one of them, so I just deleted the second one because it didn't apply with what I needed for E. coli. Then I went to sequences and copied the FASTA. I repeated the process again for BioD. As you can see, this process was much faster than NCBI because everything in UniProt is curated and you can find it all in one place. For this one, there were 2 results, so I clicked on the first one for BioD1. And I looked to see if the EC number matched what I had, and it did. So I went ahead and copied the sequence. And for the last one, you already know what I did. I looked it up, or I queried specifically with the gene name Escherichia coli K12MG1655. Here there were multiple results, but I specifically clicked on BioB because that is the gene I was searching. I looked to see if the EC number matched, which it did, and then I copied the FASTA file. And that's how I got the entire biotin synthesis pathway through both NCBI and UniProt.